So in this session we are going to discuss about the blockers and modulators or the ion channels. The blockers are permeation is blocked. The ion channels are blocked. Blockers block the permeation. Next is modulators. So the modulators increase or decrease the permeability of opening a ion channel. So the blockers completely or permeation block. The permeability means the upper layer of the permeation layer is blocked by blockers, and modulators increase and decrease the opening of probability. Next is agonist normal substrate or abnormal product or agonist inhibitors. Prodrug. Agonist substrate, the agonist inhibitor, agonist or in the inhibitor. The blockers contain agonist or inhibitors which block permeation is blocked, and modulators contain increased or decreased opening probability. Increased or decreased opening probability. Next is altered gating or channel block. In GPCR ligand, the GPCRs goes to the second messengers, which are pKa or pKc, which goes to the phosphorylation, which then pass to the receptors. So this is from the www.studentconsultant.com. So there is altered gating. The gators are altered by the GPR ligands. Those are GPCRs ligands. So the GPCRs ligands sends second messengers. So second messengers are pKa or pKc. So thus phosphorylation occurs in the receptors. So the ligands contain a tetrodotoxin and saxitoxin or conotoxin. So the block of inactivation is done by veratridine, batrachotoxin, scorpiotoxin, or DT pyrethroids. Next is channel blocks. Channel blocks are done by local anesthetics, anti-epileptic drugs, phenytoin, anti-dysrhythmia drugs, example disopyramide. Next is the altered gating. So there is one receptors, next is ligand gated ions, and there is enzymes. In ligand gated ions there is drug acting antagonist, modulators, and indirect agonists. Three mechanism of antagonist: block ion channels, external channel blockers, internal channel blockers, and channel inactivators. So the local anesthetic blocks sodium channels in nerve cells and inhibit sodium influx, inhibit action potential. So the ion channelopathies, abnormality in various ion channels contribute to rapid growing of cardiac and neurological diseases. So there are different channelopathies which are abnormality in various ion channels contribute to rapidly growing number of cardiac and neurological diseases. So the mutated cardiac potassium ion channels causes long QT syndrome. Other mutated potassium channels causes deafness and epilepsy. Type of deafness familial. Next is drug. Calcium channel blockers. There is three distinctive groups: phenylalkylamines, verapamil, dihydropyne, nifedipine, and amlodipine, and benzodiazepine, which is dialtazam. Benzodiazepine. So in this we can easily study that this gating or how the channel blocking or block of inactivation or channel block is done. So there is altered gating method and channel blocking method and block of inactivation. Veratridine, batracotine, batracotoxin, scorpiotoxin, and DTT pyrothroids. So the altered gating second messengers are PKA, PKC, phosphorylation. So the channel blocks local anesthetics, anti-epileptic drugs. So local anesthetic by channel blocking, ion channel blocking. So anti-epileptic drugs are phenytoin, antidicerthymic drug, disopyramide, veratridine, batracotoxin, scorpiotoxin, DDT pyrothroids, tetrodotoxin, saxitoxin, conotoxin. All these toxin causes channel blocks and altered gating. So in this there is no altered gating is not explained, only the mechanism of local anesthetic and abnormality in channel ion channels contribution of this or the diseases or the abnormality, and there is beta adrenergic receptors, and so the three drugs which are calcium channel blockers which is angina drugs, and then there is blockers and modulators only. The action of modulators that it increase and decrease opening for probability. Net indirect agonist in case of G protein linked ions. So it acts as agonist. Agonist means it shows effect by transduction mechanism or direct method. In direct method, the ion channels opening and closing occurs. Transduction method, enzyme activation, inhibition, ion channel modulation, DNA transcription. In agonist, there is no effect or endogenous mediators are blocked. Next we are going to discuss about prodrugs. It is in the enzymes. So what is enzyme? The normal bodily enzymes are often targeted by drugs for multiple reasons. So the enzyme are targeted by drug activity or the drugs itself for reasons. So the drug act as inhibitors. So inhibit what reactions are inhibited. Example, captopril that inhibit ACE inhibitor, and next example acetylcholinesterase that inhibit prolonged ACH in synapse. Next is false substrates, which is drug molecule that undergo chemical reaction transformation, forms an abnormal product. Drugs that put enzyme out of active duty by wasting their time. The drugs false substrates are drugs molecule undergo chemical transformation, so forms an abnormal product. So the drug that put enzyme out of active duty by wasting their time. So the drug that put the enzyme out of activity or active duty by wasting their time. Next is prodrug. The enzyme converts them into active forms. The prodrug activates enzymes into their inactive to active form. that is the use of prodrugs. So in inhibitors, the reaction is inhibited. In false substrate, the drug molecule undergo chemical transformation. So, or the chemical is an enzyme, false substrate is an enzyme that causes the chemical transformation occurs, form an abnormal product or abnormal metabolite produced. Next is prodrug. The enzyme converts them into their active forms. Next is fourth one, the transport carrier proteins. So transport carrier proteins are membrane bound proteins that aid in transporting molecules that are too big or polar across the PM. They exhibit recognition site that makes them specific to their cargo, which can be targets for drugs. So the drug acts as either inhibitor or false substrates. So these transport or carrier proteins that are membrane bound protein, membrane connected protein. So they aid in transporting molecules that are too big or polar molecules across the permeable membrane. They exhibit recognition site that make them specific to their cargo, which can be targets for drugs. So what happens in transport carrier protein? They exhibit recognition site that make them specific to their cargo, which can be targets for drugs. Thank you.